Okay, so now we're putting all of our expertise on exponents together. This says to simplify each expression using the properties of exponents, and then we will write our expression in radical form when necessary. Now we only write our expression in radical form at the very end if our expression ends up having any fractional exponents. If we don't have any exponents that are fractions, then we just leave it as a normal whole number like we're used to. So let's get started. This is going to apply everything that we learned in the exponents unit, and it could apply what we've learned in the radical unit, or the radical lessons. So, number 1, we're going to multiply the coefficients. A 2 times a 2 is a 4. And then we multiply our c's. A c to the 3/5 power times a c to the 1/5 power. We keep our c, we add our exponents. A 3/5 times a 1/5 is a 4/5. Now, because the c has a fractional exponent, this will be written in radical form. The 4 is going to remain on the outside of the radical because technically the 4 has an exponent of 1, which is not a fraction. The c is going to be written in radical form, and the denominator, remember, is your index, so this is really the 5th root of c to the 4th power. And that is your answer. You cannot do the 5th root of c to the 4th power because your exponent of 4 is smaller than your index of 5. All right, the next one, an a to the 1/5 power times an a to the 3/5 power. You keep your a, you add your exponents, you get an a to the 4/5 power, which you should have experience with 4/5 because we just did it in the first one. This would be the 5th root of a to the 4th power. All right, number 3. This 1/3 needs to be attributed to both the a and the b. So I have an a to the 1/3 times a b to the 1/3. And then I have another b to the 1/3. Which means that I can combine the b's. So I have an a to the 1/3, and a b to the 1/3 times a b to the 1/3 is a b to the 2/3 because I have my exponents. Now, my a and my b both have fractional exponents, so we're going to write our answer in radical form. And if we notice, the denominator of both the fractions on a and b are the same. So that means the index is the same. So we're going to write this underneath one radical. This is going to be the cubed root of a. And you can write a to the 1st power if you wish, or just leave it as an a. And then b squared. And that's your answer. Okay, number 4. I have a 16 to the 1/2. An x to the 1/2, and an x to the 1/3. Now, something to note is the 16 to the 1/2 is the same thing as the square root of 16, which you guys should already be familiar with. And then x to the 1/2 times an x to the 1/3. We're going to need to add those exponents, but they don't have a common denominator. So we do need to get a common denominator. The common denominator would be 6. A 1/2 times a 3/3 would give you a 3/6. And a 1/3 times a 2/2 would give you a 2/6. And so I wind up with x to the 5/6 power. The square root of 16 is a 4. That's just fully simplified there. I'm only going to write the x underneath the radical. And that's going to be the 6th root, because the denominator is 6, of x to the 5th power. And that's your answer. Okay, number 5. It will help to simplify some things. So if we see in the numerator has a 5, the denominator has a 5. So both the numerator and denominator are divisible by 5. A 5 divided by a 5 is a 1, so those 5s just cancel out. So now my numerator, I have an x squared, and then a y to the negative third to the third. I'm going to multiply those two exponents, so I get a negative 9th power, and a z to the squared to the third. I multiply those exponents to get a 6th power. And so then, in my denominator, I just have that x cubed y to the 4th power. Okay, so we do need to simplify some things. My x's, an x squared divided by an x cubed. The x with the largest exponent is in the denominator. So my x is going to be in my denominator, and I subtract my exponents. The large exponent of 3 minus the small exponent of 2 would give me an exponent of 1. You can either write x to the first power in the denominator, or you can just leave it as an x. When you type in answers, I'm going to just have you leave it as an x. Don't do x to the first power, just leave it as x. All right, my y's. Out of a 4 and a negative 9, a 4 is the larger of the two exponents. So that means the y is going to wind up in the denominator because that has the larger exponent here. And the large exponent minus the small exponent of 4 minus a negative 9 is a 13. And then that z cannot be combined with anything, so it just remains in the numerator as a z to the 6th power. All of the exponents are positive, so you do know that this is simplified, and we condensed it down to only having one x, one y, and one z. All right, number 6, there's multiple ways that you can do this, but looking at your numerator and looking at your denominator, they both have 3's in them. So let's go ahead and cancel out those 3's. 3 divided by a 3 is a 1. We take care of those 3's right away. So in my numerator, I'm left with a 4, and then an x to the 6th power times an x to the 1st power would give you an x to the 7th power. And then I have a y squared, and then I have an x to the 4th, y to the 4th in my denominator. All right, simplifying some things here. My 4 is going to stay in my numerator. The x, the larger exponent, is in my numerator, so the x stays in my numerator. A 7 minus a 4 is a 3. The larger exponent of y is in the denominator, so y will move to the denominator, and a 4 minus a 2 leaves you with an exponent of 2. And this is fully simplified. All right, next one. So for number 7, 4 and an 8 are both divisible by 4. If I divide 4 divided by 4, that 4 cancels out to be a 1. If I divide 8 divided by 4, that 8 cancels out to be a 2. So there's a 2 in the denominator when I simplify the numbers. Now I'm going to work on the variables. So I have an x to the negative 2nd, y to the 4th in my numerator. I have an x to the 3rd, y to the negative 6 in my denominator because I have a negative 2 times a 3. All right. So, starting to simplify, the 2 is going to remain in my denominator. The x will be in my denominator because a 3 is greater than a negative 2. So a 3 minus a negative 2 gives you a 5th power. And then the y is going to be in my numerator. A 4 minus a negative 6 is really a 10. And now that's fully simplified. Okay, moving on to number 8. A 2 times a 4 is an 8. An a to the 6 times an a to the 1st power is an a to the 7th power. And then I have an 8a cubed. An 8 divided by an 8 cancels out. A to the 7th divided by an a to the 3rd. The 7's in the larger exponents in the numerator, so the a will stay in the numerator. A 7 minus a 3 is a 4. So I'm left with an a to the 4th power. Notice I'm not writing any of these 5 through 8 as radicals because none of them have fractional exponents. So I don't need to write them as radicals. All right, number 9. Between a 10 and a 5, both the 10 and 5 are divisible by 2. A 10 divided by a 2 is, divisible by, not a 2, a 5. A 10 divided by a 5 is a 2. So I have a 2m to the 6th power, n to the 3rd power in my numerator. All over, a 5 divided by a 5 is a 1. If you want to write that 1 in there, you can, or you can just write the m squared n to the 7th. Does not matter to me. But I simplified the numbers. Now I'm going to work on the variables. So my m, well, my 2 is going to stay in the numerator. My m will stay in the numerator 2 because a 6 is greater than a 2, and a 6 minus a 2 is a 4. So I have an m to the 4th power in my numerator. My n is going to stay in my denominator because the 7's bigger than the 3. And a 7 minus a 3 is a 4. So I have an n to the 4th power in my denominator. And that is fully simplified. All right. Looking at number 10, it might be helpful for you to first do the 3 squared, which is a 9, and then m to the 5th power, t to the 6th power, and then do the 3 to the 5th power in your calculator, which is a 243. And then we have an m to the 7th, t to the negative 5th. Now both 9 and 243 are divisible by 9. A 9 divided by a 9 is a 1. So I'm left with the m to the 5th, t to the 6th in the numerator. And a 243 divided by a 9 is a 27. And I'm left with the m to the 7th, t to the negative 5th in my denominator. Now I'm going to simplify from there. So my m is going to move into the denominator because a 7 is bigger than a 5. And I'm going to have a 27 m to the 7 minus 5th power, which is a 2. My t is going to be in my numerator. A 6 minus a negative 5 is an 11. And that's fully simplified. All right, next one, 12 and a 4. 12 and 4 are both divisible by 4. 12 divided by a 4 is a 3. A 4 divided by a 4 is a 1. So I just have a 3 left in my numerator. And I have the a to the negative 1st power, b to the 6th power, c to the negative 3rd power. And I have an a to the 5th power, b to the negative 1st power, c to the 5th power. Now I'm going to take care of those variables. So my a is going to go into my 3 is going to stay where it's at. My a is going to go into my denominator. A 5 minus a negative 1 is going to be a 6. My b is going to move into my numerator. A 6 minus a negative 1 is a 7. And my c is going to go into my denominator. A 5 minus a negative 3 is an 8. And that is fully simplified now. All right, looking at number 12, both the numerator and denominator have a 3. So the 3's cancel out. And I'm just left with an 8 in my denominator. Let's actually just simplify right away. So an x to the 5th power divided by an x to the 1st power. My x is going to be in my numerator. X to the 4th power, 5 minus a 1 is a 4. Now, my y is going to be in my numerator. And negative 4 minus a negative 9 halves will give me a 0.5, or a 1/2. And my z, a z cubed divided by a z cubed, cancels out. Now what's interesting about this one is we do need to write it in radical form. I have an x to the 4th power times y to the 1/2 is the same thing as the square root of y, and then all over 8. That's my answer. Okay, I'm going to have you try 13 and 14 by pausing the video and then unpausing to check your answers. Okay, here are your answers to 13 and 14. Moving on to 15, we're going to write our expression in exponential form. So number 15 would be 2a to the exponent of a is 1, and then the index is 3, so to the 1/3 power, plus 3a to the 1/3 power. Now, like terms means the variables are the same with the same exact exponents. So both of these are like terms, meaning we can combine them into a 5 to the 1/3 power, but here we cannot combine